In this day and age, we can design and create all kinds of things with machines. We got machines like this 3D printer here that can make models or actual parts for something for your car or for products something for a cell phone or all kinds of things. Sometimes they're used for prototypes as well. We also have machines called CNC machines that will cut parts out of metal or out of wood and make very useful things. There's a lot of math that's involved in the measurements because these are very fine machines that make things very precise. And so those calculations are very important. So in this lesson, we're going to talk about how to use technical drawings and how to calculate different values based off of measurements that we know to find measurements that we need to know. So let's dive into it and see how we can use calculations and technical drawings to find important measurements.
In this section, we're going to see how we can use decimal numbers and fractions to do some computations for some technical problems, specifically dealing with measurement. So let's take a look at this part here. Here's a part might be made out of metal or some kind of plastic. And manufacturer wants to design this, probably using a computer, and cut out on a CNC machine. And so we need to find some different lengths so we can program the computer to build this, all right? So we've got some technical things here. This R here means the radius. So this is a circular object here. So this is the radius, and the radius of this side is given there. And this obviously be the distance between the posts there. So we need to find these two values, A and B, to start with. Well, the length A here, this is the diameter all the way across. And if this is the radius, hopefully we have some experience with circles, and we know that that radius is from the center to the outside there. So that's going to be 2.18. And this is going to be 2.18 there. All right. So A is just two radiuses. You see that? 2.18 and 2.18 there. All right, so you can say 2.18 plus 2.18 or 2.18 times 2. So we want to practice writing these things out because in most cases the calculator can do the work. Hopefully you can do this one here. But, if you can write it out properly, then you can type into a calculator properly. This one we'll just do because 2 times 2 we know is 4, and 2 times 0.18 is like 18 cents, and that's like 36. Okay, and those are centimeters. Well, how about B here? Well, B is this distance all the way across here. So, well, what does that include? That includes the distance from these 2 points, these 2 centers, which we're told down here is 5.132. So we have this kind of distance from here to here. That's 5.32. Sorry. Let's see if I can write. And then this is in little distances. Well, these are just the same as the radius. You see that? 2.18. Remember, the radius of a circle is the same in all directions. Okay? So what do we have there? We got a grand total of 5.32 plus 2 of those 2.18s. So we can say B is 5.32 plus 2 of the 2.18s. And you can punch that in a calculator and you get 5.32 plus this thing right here, 9.68 centimeters. All right. That's the idea there, right? So if we scale this up now, okay, so sometimes we want to take this part and we want to make it larger. And this is just a small version of it, and we want to make it larger. That's called scaling up. So if we're going to scale it up by a multiple of 6, we'll just multiply each of these dimensions by 6, okay? It says the new height and length? Well, these are the heights and the lengths here, okay? So the height is going to be 6 times that height that we got, 4.36. And using a calculator, this is Desmo's scientific calculator here, is a nice one. 6 times 4.36 gives us 26.16. 26.16. And that is centimeters. Okay? So that's the height. Well, what's the length? That B number that we found there is the length. So we're going to multiply that by 6. So we're scaling up by 6, so 6 times 9.68. Come on over here to our calculator. And it looks like we got 58.08 centimeters. 58.08. So there we took a part and we wanted to enlarge it, so we had to find the larger dimensions. Sometimes we want to scale it down, all right? So we can scale something down by a factor. When we scale down, that's going to mean divide, okay? So scaling down, we're going to take and we're going to divide that. All right, so if we take our height, our original height, let's scale down the original one. That was 4.36, and we're going to make that 1/4 of what it is, all right? So we can have like a 1/4 scale model here. So using our calculator, 4.36, and if we divide it by 4 there, we get 1.09, it looks like. That's something we probably could have done by hand. Makes sense, 1.09 centimeters, okay? There's our new height if we scale it down 1/4 model. Our new length, well, let's take that. What do we got? To 9.68. And let's divide that by 4. Okay? And we divide that by 4. Well, all right. Let's see, can you do that? 9 divided by 4 would be 2. That makes 8, and then that leaves 1.68. 1.68 divided by 2 is 0.84. You can go plug in the calculator and you'll get that as well. All right. So scaling up, we multiply. Scaling down, we divide. All right. And when we're finding those missing measurements, we're just going to add and subtract in most cases, or double. You know, we could have added 2 of these, but doubling is easier. All right. One more here. So at the beginning there, you saw a 3D printer that was printing some parts. Sometimes, though, when we're making metal parts, especially like flat metal parts, we cut them out of big rectangles of steel or plastic. All right? And so here we have a part that we want to cut out of a larger, flat, rectangular plate steel, we call it. All right? So we've got one big rectangle, and we're going to cut a bunch of these parts out. All right? So we want to have 12 rows and 5 columns of these parts, okay? So we got 1, 2, 3, 4, 5. And then we're going to have 12 rows. Can't quite fit them in there. I'll just do a dot, dot. So there's 12 of these here. 12 rows and 5 columns, okay? Now, what we want to do is we want to figure out here, how big of a piece do we need in order to get all these parts on there, all right, using these measurements, all right? Now, first thing we're going to need here is we're going to need the total height and width of this again. Now, these are in fractions, so we'll need a little fraction practice here. Now, as we go through this course, we'll we'll work a lot more with fractions. We'll try to keep it kind of simple here. In fact, well, we'll see. It'll get simple. So here our radius. Again, this R means the radius. That's 2 3/4 and 2 3/4. So this height here is going to be 2 times 2 3/4, all right? Or we just add them. So our height here is 2 3/4 plus 2 3/4. Well, let's try that out. We know 2 plus 2 is 4. And we know 3/4 plus 3/4 is 6/4. Okay, think about money. If you have 3 silver quarters, like money, and you have 3 silver quarters, you have 6/4. Okay, we'd like to clean that up a little bit here. So let's remember some fraction stuff. Okay, remember we can simplify fractions if we divide the top and bottom by the same thing. Let's divide top and bottom by 2 there. That's 3 halves. Okay, and 3 halves is really just 1 1/2, right? Remember that? 2 goes into 3 once with 1 left over. So this is like 1 1/2. So if you had 3 half-dollars, you'd have 1 1/2. Well, we have 4 plus the 3 halves, or 4 plus 1 1/2. Okay, is what's going on. So this is 5 1/2. Okay, or 5.5, we'll say. Okay, we can make this decimal. Another way to do that is to go to your calculator and just take 2 times. Let's make this. Remember, 3/4 is 0.75. So we could do 2 times 2.75. And we'll work more with fractions as we go. So either way you do it is fine. For now, 5.5. All right, and these are all in centimeters, I believe. No, sorry, they're in inches. Okay, because this is all in inches. These 2 little marks. All right, first little introduction here. Okay. So these are in inches. So this little symbol here means inches. That's inches. You have one symbol, that's one little tick mark, that's feet. All right, and our width here, let's go and figure that out. All right, we're going to need that. Our width is 7 5/8 plus the radius over here, 2 3/4, plus the radius over here, because this width, there's our radius there, and there's our radius. So that's 2 3/4. So to find this total width, we're going to need to take the 7 5/8 and add a couple 2 3/4. Okay? That's going this whole distance. We kind of did that in the problem before. Well, all right. We can add this with fractions. We can add this with decimals. We'll dive more into fractions, like I just said. But if we want some fractions you're familiar with, 3/4, hopefully you're familiar with. That's 0.75. If you're not, okay, familiar with that, then go to your calculator. And 3/4, 3 divided by 4 is a fraction, 3/4. So fraction means divide. So if we take 3 divided by 4, notice this particular calculator even writes it as a fraction. So 3/4 is 0.75, 5/8. Let's go ahead and do that one. So the other fraction we had was 5/8 there, all right? So 5/8 is, what did we just say? 0.625, all right? So this is 7.625. So 7.625 plus 2.75 plus 2.75. Let's figure out what that is. So 2.75. Oops, sorry about that. Let's try that again. 7.625. And it looks like we got 13.125. 13.125. All right. So that's our width, 13.125 centimeters. Now, what are we going to do with that? Oh, that's not centimeters, it's actually inches. So now we have the width and height of one piece. Okay. So we've got these spaces, and these pieces spaced out, and we know that there's 3/4 inches or 0.75 in between each one. Now to figure out this total length here, notice this, we have the length. We have 5 lengths, and how many gaps do we have? I'm going to call these gaps. We have 1, 2, 3, 4. So notice we have 5 of the lengths and 4 of the gaps. So to do this, get this total length, we need 5 of the little lengths. I'll call that L. Okay, there's my L there. Plus 4 of the gaps. Well, what does that mean? That means we have 5 of these 13.125s plus 4. Notice there's 4, not 5, but 4 gaps at 0.75. So if we go punch on the calculator here, so we have 5 lengths and 4 gaps, we get 9.5625. 9.5625, all right? 9.5625, and that is inches. All right? What about this? So this width here, that's how wide it needs to be. What about the height? Well, we have 12 parts, and so we have 12 of the heights, and then how many gaps do we have? Well, notice that the gaps are below each one, except there's no gap down here at the end. So we have 12 parts, but there's only a gap under 11 of them. So there's 11 gaps, or 11 spaces, all right? So we have 12 parts plus 11 gaps. So our total height is going to be 12 of the H's, heights, these things here. Okay, these heights over here. Plus 11 of the 0.75s. 11 of the gaps. Okay, so that's 12 of the heights was 5.5, and then plus 11 gaps that are 0.75. Okay? 12 parts and 11 gaps. Okay? And we'll just multiply that. Let the calculator do the work is fine. 74.25. Okay? So 74.25. And that is inches. So the total height of this is going to be 74.25. All right? Okay, so that's how big a piece we need. 74.25 by 9.5625. All right, that's how it works there.